This video will be a video answer key for force practice set number 4. So if we're finding the mass of an object that accelerates at 5 meters per second squared with a force of 50, we're going to set up 50 equals 5 times m. We're going to find that the mass is 10 kg. Find the mass of an object that accelerates upward at 15 meters per second squared with a force of 50 newtons. So we're finding the mass. So 50n, total force, is going to be equal to the mass times a rate of acceleration. If it's going upwards, this upwards is a hint that we're also fighting the force of gravity. So the rate of acceleration is going to be 10 plus 15, or 25. Divide both sides by 25, and your mass is going to be 2 kilograms. So to explain this one a little bit more, that force of 50 newtons is used to accelerate, is used to throw the object up, which means I not only have to balance its weight, but I have to also move the object. So I need to account for the rate of acceleration due to gravity in addition to the goal of accelerating it at 15 meters per second squared. So I need to know that if it's a 2 kilogram object, 20 newtons, 2 times 10, 20 newtons of that will be spent just supporting the object's weight. The other 2 times 15, the other 30 newtons will go to actually accelerate it upwards. Find the mass of an object that accelerates on the table at 5 meters per second with 10 newtons of friction and a 50 newton push. So 50 newtons is going to be equal to the friction, 10 newtons, plus the rate of acceleration, 5 times m. So subtract both sides, subtract 10 by both sides, so we've got 40 newtons equals 5m, divide 5 from both sides, and we've got the mass is going to equal 8 kilograms. There's a 10 kilogram mass, so let's draw this out. 10 kilogram mass hanging, subtract to a 20 kilogram mass. How fast will the block on the table accelerate? So this is going to go downwards, 10 times 10 with 100 newtons of force. 100 newtons of force acting on that 20 newtons up top. It's going to be 5 meters per second squared. 25 kilograms, 500 newtons of force. How fast will it accelerate? So 25, 500 newtons total. So we're going to say 500 newtons is the total force, is going to be equal to the force of gravity, 25 times 10, plus the force of the rocket, which will be the mass, 25 kilograms, times the rate of acceleration of the rocket. So this will give us 250 equals 500, so plus that 25a. We subtract this 250 from both sides, so we're left with 250 equals 25a. Divide both sides by 25, and our a is going to be 10 meters per second squared. The other way that we can solve this is to say 500 is going to be equal to 25a. Now that a we know has to account for acceleration due to gravity and the acceleration of the rocket. Divide both sides by 25, and our a is going to be 20. We subtract the 10 meters per second of acceleration due to gravity, and we're left over with 10 meters per second of the acceleration of the rocket, which matches. I always like doing it both ways because then I can just double check my work. This statement can be true or false. Explain both sides. The stronger the force, the faster an object moves. Well, if we're just talking about F equals m times a, if we're talking about the same mass, right, a 10 kilogram object, no matter what, if I make the force bigger, the acceleration is going to go up, right? I throw a ball harder, the ball will move faster. So this is an intuitive statement that yes, because force and acceleration are directly proportional, therefore the harder I throw something, the faster it will move, the stronger the force, the greater the acceleration. However, what if the stronger force is actually friction? If friction goes up, acceleration will not go up, acceleration will go down. So in general, yes, force and acceleration are directly proportional, therefore a greater force applied means a greater acceleration, unless that force is an opposing force or is a force of friction, which is also an opposing force. If your opposing force gets bigger, you're actually going to move more slowly.